Okay, now we are going to look at joint variation, which is very similar to direct variation, except for that you have more than one variable that affects the outcome. So for instance, here's an example of joint variation. The price of a house would increase as the square footage of the house increases and the quality of materials that you use increases. Okay, so if it gets bigger and you use better materials, then your price will get higher on the house. Okay, so two things now are affecting the outcome. You're still going to multiply by those variables, and so your basic equation, generic equation, is right here. Y equals k times x times z. All right, so here we go. First sentence, y varies jointly as x and z, so you will go y equals k x z. If it said it would vary jointly as x squared and z cubed, then it would be k x squared z cubed. So you're going to have to just sort of pay attention to this. Find y if x equals 8 and z equals 3 if you know that when y is 16, x is 2 and z is 5. You actually have to use that part that I underlined first. So you'll go 16 equals k times 2 times 5. So 16 equals 10k. So k is 16 tenths, which of course we know to be 8/5 when it reduces. So I used that. I am not going to use it again. Now I'm going to go back to this equation, and I want to find a new y, which I don't know. I now know that my k is 8/5. My constant that I multiply every time is 8/5. And I know that my x is 8, and I know that my z is 3. And when I multiply that whole entire top out, 8 times 8 times 3, I get 192. And my bottom, 5 times 1 times 1, gives me 5. So this is my new y value. All right, very similarly, again, y varies jointly as x and z. And it might not always be exactly x, it might not always be exactly z. It might be the square root of x and z squared, or whatever. But this is kind of your basic generic equation that we will use. So you're wanting to find, first of all, the spot where you know 3 variables, because I have 4 variables here, and I need to know 3 variables so I can find that k that's unknown. So I will use this first. So y is 12. I don't know k. I know x is 8 and z is 3. So I have 12 equals 24k. And then k, of course, will be 1/2. So you will use that. Again, you will plug it back into this generic equation here, or the equation that fits this problem. I don't know my y this time, but I know that my k is 1/2. And I know that now I'm not using this anymore. I'm using this. I now know that x is 10 and that z is 5. So 10 times 5 is 50, and 1/2 of that, of course, would be 25. So that is your new y value in this case.